two types of, I guess, variables in LogiX. Obviously, you've already seen the inputs, or it's just a static variable. You can think of these as constant. They don't change. Once you type in the value, that's the value. You can't change it until you open up LogiX again, type in the value, pack it back up, things like that. It's sort of just used, what we call these as magic numbers, magic variables, where it's not really obvious why it's there, but it's there for a reason, right?
Okay.
So earlier on, I had x equals 4. This is not that. This is just 4. This has no name, right?
So
it can't be
it's
changed.
just a number character.
It's just a number. It has no way to be changed by the program. The only way it would be changed is if you were to open up the program and type in a new value.
Gotcha.
So and to have things that we can change, we use what are called variables. So in here we have float, and this is the same thing as this. They both equal 0, except this one can be changed by the program by using a write. This is an action, actions, and then writes. And writes are just going to write to a variable. So we can plug this right here, which is the target, into the variable that we want to change, and that creates this little arrow. The arrow doesn't matter. You can put it anywhere you want. It's connected to this now, though. No matter what you do, it's always going to be writing to that. And we can put any number in here. And this works of any type. You can put booleans, strings, anything. And we type in anything in here. And once this is pulsed, it changes this number. So that means that this kind of value can be changed by the internal system that you build. That is very useful pretty much everywhere. If you want a state of your game to change, if you want a state of your machine to change, if you want a state of your object to change, say you let go of an item and it should, I don't know, explode. You let go, suddenly, write true to explode or something.
Okay.
Basically,
Gotcha. So it bypass it. Okay, I understand. I got to figure out a way to put it into my own words, but essentially, float is a representative of this right here.
Hold on. I got my cables under my chair. Oh no. Oh, there we go. All right, go on.
Okay, so the number at the top, that was that an integer? No, what was that again?
A float.
Float. Then that's a float value? Wait, okay, so what's the...
So this one can't be changed by the internal system because you can't write to these.
Okay.
These ones, however, can be changed by the internal system.
And where did we find the difference between these two again?
They are either in inputs, which is this one, as it's just a user input, completely unchangeable by the system. And then these ones are variables that can be changed. And you can usually, right now we don't have the support in LogiX, but hopefully at one point we'll be able to rename these nodes. So this could be maybe current velocity of my system. My system is going to be moving at a specific speed, and I want to know what that speed is. It's also getting affected by gravity and things, so that's going to be my velocity.
Gotcha. So you could label that later, but right now it's just all called float.
Yeah.
Okay.
Later on, hopefully we'll be able to label it, but there is here actually a very good use case. A float would be used for the velocity, but the velocity is affected by gravity, which is a input. Gravity is just negative 9.812, right? It's just an input that affects this. So we would have gravity as one of these, and we'd have velocity as one of these. Because gravity doesn't change.
But velocity does, because you can speed up or slow down.
Exactly.
Okay, so you can input this. That's exactly what you do. You input in there. So you could input gravity in there, which is, what was it again?
Negative 9.812.
9.812. All right, so that will never change unless I go through and change it in my original, but generally speaking, that does not change. That's constant.
Exactly.
Okay.
Yep. And that's
Alright.
actually what they're called in programming as well. These are what we call constant variables, denoted by the term const.
Okay, great. And then this in turn would designate the velocity. So velocity could be 9.
Yeah, and this could be a self-cycling system. We could say that velocity is equal to the velocity that we currently have plus an acceleration. So maybe 1 is our acceleration. So instead, we're going to write this. And now every time we pulse, it adds 1. So we're increasing our velocity over time. And when I say time, I mean we could literally put this on a timer. And this is automatically going to pulse. Right now it's doing it every frame, so we're going to set it to 1, and now it's every second. So it'd be every second we are increasing our velocity by 1. So now we have an automated system just increasing velocity.
Oh, nice.
This is basically how I build my physics in Neos. Though I actually have to use real physics equations, this is just a simplified example.
Gotcha. And essentially what it's doing, the timer is automatically set to 1 second, that little gray.
This right here is the
Oh,
interval. That
okay.
is the user that the timer is running on. By default, it's the host.
Okay. So that would be more advanced probably than what we're doing right now.
Probably.
Yeah, okay. I can put that aside then.
When we think about how this is impulsing, it does not matter what is impulsing the writes. The timer is just a something to show an example. We could put that on an update which runs every single frame, but then we'd have to start accounting for like frame rate inconsistency and things, and I think that's a bit ahead of where we are.
Yeah.
But this is pretty much all you need to know to understand logic systems. I have a few things that I have. I'll show you one blueprint today, and we'll go through and try to figure out this is something I really use in real logics. So this is a true example of a logical system that I have built. Now, I haven't explained this yet, but it's what we call a for loop, and a for loop is going to run a fixed amount of times. So we can have maybe 5. I want this for loop to run 5 times. We have when it starts, when it iterates, every time it iterates, and when it ends. So it's going to pulse once when it starts, 5 times for the 5 iterations, and once when it ends. This number here is just the iteration that it's currently on at this impulse. Now, this might not be intuitive because this happens all immediately in one frame. There is no time between the impulses other than the time on your CPU that it takes to run the cycles.
Okay.
So if I was to impulse this, it would look like it just pulsed once. You can see that it actually pulsed 5 times.
This one did 5 times, that one did once, that one did once?
Yeah.
Okay.
Yeah, you can see there how many times it fired. Total.
Okay. So what do each of these indicate?
The start of the cycle iterations, and the end of the cycle. So if we're to write this out, we have a loop running, and this is going to have start, and we're going to put a plus at every time it impulses. Now we have 5 designated to this, so it's going to run an impulse once, twice, 3, 4, 5. And once it's finished doing those 5 impulses, it will do an end impulse. And then after that is all done, it will pretty much stop there. And to have that keep going, we would have to have what's called like a while loop. But don't use while loops if you don't know how to use them. Even I try to avoid them. Okay. Not because I don't know how to use them, but because they're just dangerous.
Gotcha. It sounds like wild.
Have you ever heard of while true?
No.
Basically, while loops keep running, they keep functioning while there is something that is true.
Gotcha.
So if you have a while true, you crash your system
Because it will never
because
stop.
because it will never stop. It will hang your system. LogiX actually has a safety in place. So if it detects that it's running too many times, then I'll press this, I'll freeze because it's hanging my system, and then after a moment, it will break the node because it recognized that it's taking too long.
Gotcha. Okay.
So we're safe in Neos, but not in programs usually. So be careful.
Okay. All right. So stay away from. To me, it sounds too much like wild, WILD. So I'll just consider it to be pretty. In a sense, it kind of is. So we'll leave it alone.
Yeah, it can be useful though. We can also think of this, by the way, as if we were to think of this as an actual function, what it's doing is it's starting, and then it's iterating, and every iteration it checks maybe is C greater than 5. In this case, how many times we're iterating. If C is greater than 5, so if it's greater than 5, then we'll have an arrow go to end. And if it's not greater than 5, then iterate again.
Okay, zoom out here a little bit so I can see what's going on. Okay, so start iterating.
And then it tries to iterate 5 times. And the C represents how many times it's iterated. That's the count.
Oh, okay, that's a C. Okay, like the letter C.
Yeah.
Okay. So it iterates, and then greater than. You said the greater than thing.
Yeah. Well, actually,
If it's greater than 5, then end. Okay, that makes sense.
Yeah.
So it's going to go 5 times, and as soon as it gets to 5.00000001, that means it's greater than 5.
Once it gets to 6, because iterations cannot be decimals, it's just once, twice, 3 times. It's an iteration.
Okay, gotcha.
Yeah, that's pretty much it, though. That's a for loop. So now we look back at this system I've constructed. Bring it forward a bit. We can start plugging in some variables. So I want 5, and I want my impulse input. And now we have this other variable. So as I said, this is the current iteration it's on. So these all happen at the same time, but every time an impulse happens, it increments this number here. That's our C that I showed down there. And by the only thing you don't know of here is the delay, and delay is literally just going to delay an impulse by a set amount of time.
So it doesn't crash your system.
Well, no, just it's just a useful function.
Okay.
Just delaying an impulse is just something you want to be able to do every so often. In this case, I want to send a burst of impulses, not all at once. I want them to be separated. So dun 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 dun, rather than all at once.
Okay.
And so what I have is I want it to iterate 5 times. I want it to multiply my input by this separation between the bursts. Say I want this to happen in 0.5 seconds. So I make it 0.1. 0.1 times 5 is 0.5. So then it's going to iterate, multiply 0.1 by the current iteration, and then delay it. By that iteration, the current iteration will be delayed by the iteration multiplied by 0.1. And then impulse. So now if I press this, we have 5 impulses over 0.5 seconds.
Okay, so let's go through this one again. We've got 5 iterations, pulse for 5 times, or 5 iterations. Now this delay here is connected across. So it says to output to the delay, But I don't understand what this is down here. I need my LogiX tip, don't I?
Yeah, this one is the iteration it's currently on. So it
Ah,
pulses 5 times, and it says on the first pulse it will say that's 0. On the second pulse that will be 1. Third pulse that will be 2.
okay. Okay, that makes sense. And then it's multiplying that by, well, okay, these confuse me. So there's a multiplier and an adding.
That's just to add more things to multiply.
Okay, so it has nothing to do with the. I gotcha. Those are just uh input variable options.
Yeah.
Okay, okay, that makes sense. All right, so multiply that times this, and then output to the delay as the delay, correct?
Yeah.
Okay, so this will say 0.1 seconds, wait 0.1 seconds, and then fire.
Yeah. And it
Okay,
will do that incrementally for each impulse 5 times. So wait, I want to send 5 impulses, but I want them to wait 0.1, 0.2, 0.3, 0.4, 0.5.
gotcha. Okay, okay, that makes sense. Now, how would you
And
use this? Like, what would be some examples of, not to say we have to make it, but what would be some examples of how to use this in a uh, real world setting?
I use this for guns. Maybe you want to burst fire on a gun. Press the trigger, trigger 5 impulses over a certain amount of time, and cause it to fire a bullet at every impulse.
Okay, makes sense.
I mean, this is pretty much all you need to know. Everything else, you just need to tinker with the nodes. Every time you come across a node, you need to look at it, try to understand it, ask someone if you don't know what it does, and if it comes down to it, just experiment with it.
Oh, great. So, pretty much once it comes down to it, I can probably build a majority of things out of what you've taught me today, but they would probably get to be so complex that I would need to understand the other nodes in order to simplify the, uh, I guess, the process, right? Make it
Yeah.
not like total spaghetti.
I think that I can't remember exactly what function it was, but do you know what Turing complete means?
No.
Turing complete basically means you can compute anything that is computable. So a machine that is Turing complete can literally compute anything. And
Nice.
like a phone is Turing complete, uh, and calculators are probably Turing complete. I'm unsure exactly, but with their set of actions, their set of operations, they can compute anything that, as long as it's programmed well, or someone is able to program it, like it would be Turing complete. And so um, there is a funny sort of thing about that. Is someone made a a series of functions out of one operator, one operation. So I can't remember what the operation was, but let's just say it was the and operation. Um, they made a machine that was Turing complete out of one operation. So theoretically, I could have given you one node and said, build stuff,
Right.
but I didn't.
Yeah, sure. Yeah, and that's Turing as in like Alan Turing.
I guess I don't know who that is,
Oh,
but
okay.
sure,
Okay. All right.
probably,
Yeah.
probably.
Okay, that's great. So now I need to build some things. What would you recommend I come up with for, on my own using what you've given me today? What homework would be good assignments? Like Leon mentioned, build a light bulb that you can turn on and off, and then build 3 light bulbs that you can switch. What would be some assignments for me to kind of work on my own to uh, complete using these lessons you
I
just
think the light bulb's a good idea. All you need to do is enable and disable a light. So maybe you can have it so that when you press a button, you would turn on the light. When you press it again, it turns off the light. And if you want to go a step further, then when you press the light, it switches its mode. So first it stays on entirely. You press it again, maybe it starts to flash and blink. Maybe you press it again and it starts to randomly flicker or something. And you press it again, it turns off. Just
Ah,
different modes kind of thing.
okay.
I'm happy to help if you get stuck on any of that,
But I need to do it
but
myself. Yeah.
yeah, try to figure it out. And if you can, not that I don't want to help you, but ask someone else,
Okay.
because I can explain things and I can build things, but what would be more valuable is if you could use the resources that are immediately available to you. Someone that's right next to you, someone who's just online in your friends list, someone who you don't need to bug to come online. Just work with what you've got, essentially.
Okay. That makes sense. Now, the one question I have is how does this tie back into the inspector window?
Okay, so do you know how to work with like components and slots with LogiX?
You can grab the component out and double click in it.
You press
Oh,
secondary.
secondary. And then it has that list. And then you can
Yeah,
plug things into that list and then you end up packing it and unpacking it
exactly.
basically. Okay. So that's pretty much all it is.
Yep.
Okay. Okay,
I
cool.
mean, yeah, that's it. If you have any more questions about operators or specific nodes, I'm happy to help. But I think you're pretty much set.
Yeah,
That's
this is
basically where I got started in when I first learned programming when I was 11. I was doing it with nodes in Game Maker. So it's software quite old.
and that basic, even though it's old, it gave you a basic understanding of how to think in order and use these simple interfaces and variables to accomplish what you want. Therefore, you carried it on to the rest of the lessons.
All you need is that initial mindset to carry you like anywhere. And the thing is, that basic set of knowledge is all you need. It's absolutely all you need to figure out any problem. Given enough time, mental effort, and dedication, you can figure it out. Use Google, use your peers, just work with what you've got. And one of the biggest like gripes that I have with people learning programming is they say, well, I can't do that because I don't know this. And it's like, well, yes, of course you don't know it. You need to ask someone. Please ask someone. No one can just figure something out. You need reference material. You need to work with others. You need perspectives.
That makes sense. Right on. Well,
I mean,
thank you, Coffee. I appreciate it. That was a lot of help, and I'm gonna be able to do a lot of really fun stuff now because knowing the basics I can practice, the wax on, wax off, that will give me. Which do you know that reference? Your Karate Kid? No. Okay. Um, anyway, it's about learning the basics and then applying them to everything else beyond that. So this will be a lot of help. I really appreciate it.
yeah, I mean, that's the thing is when it comes to any field, you cannot be an expert until you know the basics. You still use the most basic things way later down the line. A person who is an expert at woodworking still knows, still every single day uses that basic chisel. And it's just, you cannot jump in the deep end of that thing, which is why, again, that gripe where people are just like, I can't do this because I don't know it. Well, you can't know it without just asking. You need that initial push.
Yeah.